Welcome to my video, Introduction to Geometry and its Real-World Applications. What is geometry? Geometry is a branch of mathematics that studies shapes, sizes, positions, and properties of space. It differs from algebra because it focuses on spatial relationships and visual relationships rather than numerical manipulation. Not a lot of formulas like quadratic equations that you would see in algebra. Geometry asks questions like, what is a triangle? How do we measure angles? And what defines parallel lines? Geometry goes way back. The word itself comes from the ancient Greek meaning geo, earth, and metron meaning measure. And we trace it back easily to the ancient Egyptians who used geometry to measure land boundaries after the Nile flooded. Every year the Nile River flooded and they really couldn't keep track of exactly where the land was, so they had to do surveying, and that required geometry to reconstitute the land for people could get their land back. And plus, building the giant pyramids took a lot of geometry, math, engineering, science. And in the 3rd century BCE, a man named Euclid started organizing all the known geometry at that point and carried it a little further. And he developed what's called the elements, and these are a series of books. They're still widely read today and available. One of the most popular books on the planet, actually. Greek geometry emphasizes proof and logic deduction, the foundation of modern mathematics. So we're going to see in geometry as you study it, proof and logic is part of it. Now, in everyday life, we see geometry everywhere we go. It's really easier to say what is not involved in geometry if you talk science and technology, because it's really just about everything. So architecture, designs of buildings and bridges, sports, just analyze the angle of a basketball shot or in billiards. Navigation, your GPS system on your phone tells you where you're going. It's heavily dependent on geometry and understanding the motion of the earth. Engineering design, geometry defines shape, function, and precision. In geometry, we have 3 basic, and we call these undefined terms, which is a little bit confusing. But basically, we're going to define the point, the line, and the plane. And these are going to be kind of givens. They're going to form the basis of geometry. And a point is a location with no size or dimension. It's just kind of an infinitely small point in space. A line extends infinitely in 2 directions, made from an infinite number of points. So it goes great distances to infinity, to the left and to the right, and it's a straight line. It's made of an infinite number of points. It's a theoretical construct. A plane is a flat surface extending infinitely in all directions. So a plane just is like a flat surface of a table, for instance, but it goes forever, has an infinite number of points. These are all the foundation of geometrical definitions. An undefined term doesn't mean we don't know what it is. It means we agree on its intuitive meaning and use it as a foundation for defining everything else. It's kind of like the alphabet, forms the basis of the language. So these undefined terms form kind of the beginning, the point, the line, and the plane. And from there we build up into more complex definitions and ideas, the segment, the angle, the circle. And then we go to theorems and proof and try to see how it all ties together. So these undefined terms, the point, line, and the plane, don't let that undefined term mess you up. They are just constructs that we've come up with that help us. We build our geometry on top of that. All right, so let's start putting this all together. So points are labeled with capital letters. We just define A, B, and C, just for notation. And the lines, this would be a line right here, goes from, we said, from plus and minus infinity, and just keeps going and going. So we define it with an AB, or just the 2 letters from A to B, and we put this arrow on top that tells us that it's a line. And planes are labeled with 3 non-collinear points, like A, B, and C. And collinear means you can't put a line through them, through A, B, and C. You can through A and B, but you need a 3rd one, because if it was just 3 lines, 3 points that were collinear, then it really wouldn't define a plane. It would just define a line. So they need to be non-collinear. We're going to look at that a little bit further. So in this example, a point, lies on a plane. So we've got points on a plane, and a line lays on a plane. So that's kind of what that's showing there. We spoke just a minute ago about collinear and non-collinear, and we're going to go a little bit further. Collinear points that lie on the same line. This would be like A, B, and C. They're all on the same line. Non-collinear points not on the same line. Say if the C was down here, the B was up here, they would not be in the same line. Coplanar means points or lines in the same plane. So these form the plane of D, E, F. These are coplanar points. Non-coplanar points, they're not on the same plane. Say if you defined a point G up here that was above the plane or below the plane, like if you consider a table, a plane of a table, if it's below the table or above the table, it's not in the plane of the table. So that would be non-coplanar. Now a line segment, if you take a piece or a chunk out of a line, say from A to B, if you put a line over the top, you're just talking about these points contained between A and B. So that's the endpoints is A and B, and all the points in between form the line segment. Now a ray starts at a point, goes through another point, but it just goes in one direction. And the direction can be important depending on which way, how you define things. So that just has a arrow over the A and the B that tells you which way the line is going. So that's our symbolism for segments and rays. So in summary, geometry studies shapes, space, and relationships. Its root go back to ancient civilizations and Euclid's elements. And points, lines, and planes form the foundation. That's what we just looked at here. And understanding the relationships like segments and rays prepare us for deeper geometry concepts. So this was just an introduction to geometry, some of the basic undefined terms and defined terms, and we're going to go from here. I hope you got something out of the video and learned a little bit about geometry. Thank you for watching.